Black holes can slow time, the universe's biggest mystery. Black holes can bend time. Black hole are regions in space where gravity is so strong that nothing can escape, not even light. They form when massive stars collapse at the end of their life cycle. Their gravity bends the fabric of space and time around them. According to Einstein's theory, time moves slower near a black hole. If someone could get close enough safely, they would experience time differently. Black holes can also consume nearby stars and gas. They remain one of the most mysterious objects in astronomy. Earth's continents are always moving. Earth may look stable, but its continents are constantly moving very slowly. The planet's outer surface is divided into huge pieces called tectonic plates. These plates float on hot molten rock deep beneath Earth's crust. Over millions of years, their movement changes the shape of continents and oceans. This process causes earthquakes, volcanic eruptions, and the formation of mountain ranges. Plate tectonics help scientists understand how our planet continues to change over time. Earth is not solid, but squishy. The planet is alive under our feet. Earth's interior is not solid, but rather has a semi-solid or squishy consistency, owing to high temperatures and pressures. This squishy consistency allows the mantle to flow and move over geological timescales, which is responsible for phenomena such as plate tectonics, volcanic activity, and earthquakes. One consequence of this squishy interior is a process known as post-glacial rebound. During the last ice age, large portions of Earth's surface were covered by glaciers, causing the underlying mantle to deform and sink. As the glaciers melted and receded, the mantle slowly rebounded back to its original position over thousands of years, causing the land above it to rise. This process is still occurring today in places such as Canada, Scandinavia, and Greenland, where the land is still rebounding from the weight of the glaciers that once covered the region. Recent research had found that West Antarctica is rising faster than anywhere else in the world, thanks to data from ESA's GOES gravity mission. Earth has a squishy interior. Earth's interior is not solid, but rather has a semi-solid or squishy consistency owing to high temperatures and pressures. This squishy consistency allows the mantle to flow and move over geological timescales, which is responsible for phenomena such as plate tectonics, volcanic activity, and earthquakes. One consequence of this squishy interior is a process known as post-glacial rebound. During the last ice age, large portions of Earth's surface were covered by glaciers, causing the underlying mantle to deform and sink. As the glaciers melted and receded, the mantle slowly rebounded back to its original position over thousands of years, causing the land above it to rise. This process is still occurring today in places such as Canada, Scandinavia, and Greenland, where the land is still rebounding from the weight of the glaciers that once covered the region. Recent research had found that West Antarctica is rising faster than anywhere else in the world, thanks to data from ESA's GOES gravity mission. Earth's moon is stranger than you think. The moon, Earth, is only natural satellite, formed about 4.5 billion years ago when a Mars-sized body collided with early Earth. It is the fifth largest moon in the solar system, measuring about 3,474 kilometers in diameter, and orbits roughly 384,400 kilometers away. Discover 10 fascinating facts about our moon. It's moving away. The moon is drifting away from Earth at a rate of roughly 3.8 centimeters every year. We only see one side. Because Earth and the moon are tidally locked, the moon rotates at the same rate it orbits Earth. This causes it to constantly show the same near side to us. Extreme temperatures. Without a thick atmosphere to trap heat, lunar temperatures range from a scorching 127 degrees C during the day to a freezing -153 degrees C at night. It has quakes. The moon experiences seismic activity known as moonquakes. These quakes generally originate miles beneath the surface and are caused by the gravitational pull of the Earth. Lower gravity. Gravity on the moon is only about 1/6 as strong as it is on Earth, meaning you could jump about 6 times higher there. Ancient lava tubes. The lunar surface features vast subterranean tunnels created by ancient volcanic activity. These could provide excellent shelter for future human habitats. It has a tail. The moon is surrounded by a very thin atmosphere known as an exosphere. Solar radiation continuously pushes sodium atoms from its surface, forming a glowing, comet-like sodium tail. Water exists there. Contrary to early beliefs, water ice is hidden in permanently shadowed craters at the lunar poles. Volcanic Maria. The dark, smooth spots you can see on the moon's near side, the Maria, are actually vast, solidified ancient lava plains. Metallic traces. The lunar surface holds trace amounts of precious metals like gold and platinum, left behind by early metallic meteorite impacts. Trending title for this. Mars has blue sunsets. But that's not all. Why scientists can't stop studying Mars. Mars is a rocky, cold desert planet roughly half the size of Earth. It is most famous for its rusty red hue, caused by the abundance of iron oxide on its surface. Blue sunsets. Because the thin atmosphere scatters blue light, sunsets on Mars appear strikingly blue to the human eye. Mars has superpowers no other planet can match. Mars stands out from every other planet in the solar system with several truly unique characteristics. It is the only planet known to host the largest volcano ever discovered, Olympus Mons, towering about 3 times higher than Mount Everest. It also has the largest canyon, Valles Marineris, stretching over 4,000 kilometers across the planet. Unlike Earth, sunsets on Mars appear blue, thanks to fine dust in its thin atmosphere scattering red light differently. A Martian day is remarkably close to Earth, at 24 hours and 37 minutes, making it the most Earth-like day in the solar system. Mars is also the only rocky planet with 2 tiny, irregular, asteroid-like moons, Phobos and Deimos. Over the next 50 million years, gravitational forces will slowly pull Phobos apart, eventually forming a planetary ring of debris around Mars. Believe Mars once had rivers, lakes, and perhaps even oceans, making it the strongest candidate for ancient extraterrestrial life and the leading destination for future human exploration. A day on Venus is longer than its year. Why? Venus is one of the strangest planets in our solar system. Venus is the hottest planet in our solar system, with surface temperatures reaching around 465 degrees Celsius, hot enough to melt lead because of its thick atmosphere filled with carbon dioxide. It rotates extremely slowly compared to other planets. One full rotation on Venus takes 243 Earth days to complete. However, Venus orbits the Sun in only 225 Earth days. This means a single day on Venus lasts longer than its entire year. It also spins in the opposite direction compared to most planets. Scientists call this unusual movement retrograde rotation. Black holes can slow time, the universe's biggest mystery. Black holes can bend time. Black hole are regions in space where gravity is so strong that nothing can escape, not even light. They form when massive stars collapse at the end of their life cycle. Their gravity bends the fabric of space and time around them. According to Einstein's theory, time moves slower near a black hole. If someone could get close enough safely, they would experience time differently. Black holes can also consume nearby stars and gas. They remain one of the most mysterious objects in astronomy. Mercury's impossible world. 12 mind-blowing facts that defy space. Mercury is the smallest and closest planet to the Sun, yet it is not the hottest planet in our solar system. Venus holds that record because of its thick atmosphere. Mercury is the second densest planet after Earth, hiding an enormous iron core that makes up most of its interior. Despite its small size, it has a surprisingly strong magnetic field that interacts with the solar wind. Its highly elliptical orbit creates a rare phenomenon where the Sun appears to stop, move backward, and then continue forward in Mercury's sky. With almost no atmosphere, temperatures swing dramatically from about 430 degrees Celsius, 806 degrees Fahrenheit during the day, to -180 degrees Celsius, (-292 degrees Fahrenheit) at night. Surprisingly, permanently shadowed craters near its poles contain frozen water ice. Mercury's unique 3-2 spin orbit resonance means one solar day lasts 176 Earth days, even though it completes an orbit around the Sun in just 88 Earth days. Its surface is covered with countless impact craters, resembling Earth's moon, and giant cliffs called scarps reveal that the planet has shrunk as its core cooled over billions of years. Mercury also has an extremely thin exosphere made of atoms blasted from its surface by the solar wind instead of a true atmosphere. Two more amazing facts. Mercury has no natural moons or rings, making it one of only 2 planets in the solar system without any moons, and because it orbits so close to the Sun, it travels through space at an incredible 47.4 kilometers per second, about 170,000 kilometers per hour, making it the fastest planet in our solar system. Venus, the deadliest planet with impossible secrets. Venus stands out as a planetary enigma, a backward clockwise rotation so sluggish that its day lasts longer than its year. Despite being the second planet from the Sun, it is the hottest in the solar system due to a runaway greenhouse effect driven by a thick, 96% carbon dioxide atmosphere. This heavy blanket creates a crushing surface pressure 90 times that of Earth, turning the ground-level gas into a strange, ocean-like supercritical fluid. High above, toxic clouds unleash intense sulfuric acid rain that completely evaporates into a phenomenon called virga, before ever hitting the scorched, moonless terrain. The upper atmosphere also exhibits a bizarre superrotation where high-altitude winds whip around the entire globe in just 4 Earth days. Furthermore, Venus lacks an internal magnetic field, causing the solar wind to strip away upper gases and stretch them into a massive, comet-like tail. Its crust functions under a unique squishy lid tectonic system, which triggers periodic global resurfacing events that entirely erase ancient impact craters. Deep radar scans have even exposed colossal subterranean lava tubes, while the high clouds contain mysterious ultraviolet absorbing streaks that baffle astronomers. Finally, the recent and highly debated detection of phosphine gas in its temperate cloud decks keeps scientists actively questioning whether microscopic life could survive in its atmosphere. Why Jupiter is the king of our solar system? Jupiter is the largest planet in our solar system, holding more than twice the total mass of all other planets combined. It is a true gas giant composed primarily of hydrogen and helium, completely lacking a solid surface to stand on. Despite its colossal size, it has the shortest day of any planet, spinning fully on its axis in just 9.9 hours. This rapid rotation creates intense weather, including the Great Red Spot, a massive storm wider than Earth that has raged for centuries. Beneath its swirling clouds lies a vast ocean of liquid metallic hydrogen that generates an incredibly powerful, magnetic field 54 times stronger than Earth's. It acts as a cosmic vacuum cleaner, using its immense gravity to deflect dangerous comets and asteroids away from the inner planets. Jupiter also commands a massive system of over 95 moons, including Ganymede, which is larger than the planet Mercury. 3 of these major moons hide vast, liquid water oceans beneath thick crusts of ice, making them prime targets for alien life searches. Unlike Saturn's bright icy rings, Jupiter is uniquely encircled by a faint dark ring system made entirely of dust. Finally, it acts as its own energy source, radiating more heat into space than it receives from the distant Sun. Saturn, the planet that could float on water? Saturn's rings are disappearing. Here's why. Saturn is the 6th planet from the Sun and the 2nd largest in our solar system. It is an immense gas giant with a diameter 9 times wider than Earth, yet it has the lowest density of any planet, being so light it would float on water. The planet is known for its spectacular rings, which stretch 280,000 kilometers wide but measure just 10 meters in thickness. These icy rings constantly collide, erode, and will likely disappear in 300 million years. Saturn experiences a phenomenon known as ring rain, where a massive influx of water ice and dust is pulled directly from its rings into the upper atmosphere by magnetic fields and gravity. Saturn spins on its axis so rapidly that a single day lasts just 10.7 hours, causing the planet to flatten noticeably at its poles. Because it rotates in 29.4 Earth years, it experiences distinctly changing seasons. Its upper atmosphere is dominated by ammonia crystals and jet streams that whip up to 1,800 kilometers per hour. At its north pole, Saturn features a bizarre and permanent hexagon-shaped jet stream wider than our entire planet. It holds the record for the highest number of moons in the solar system, with 146 confirmed satellites. Its largest moon, Titan, is larger than Mercury, and is the only moon in our solar system known to have a dense atmosphere and liquid lakes. Saturn's moon Titan hosts liquid methane seas and organic chemistry, while its icy moon Enceladus shoots water plumes from a subsurface ocean. These extreme environments make both moons top targets for scientists searching for microbial life beyond Earth. Diamond rain is real? The solar system's most incredible storm. Scientists believe that deep inside the giant planets Jupiter, Saturn, Uranus, and Neptune, extreme conditions may create spectacular diamond rain. On Jupiter and Saturn, powerful lightning storms can split methane gas into carbon particles, which sink deeper into the planets. As pressure and temperature increase, these carbon particles may be compressed into tiny diamonds. Inside Uranus and Neptune, immense pressure is also thought to transform carbon into diamonds that fall through the planet's interiors like rain. Some of these diamonds may eventually melt into liquid deep within the planets. Scientists have recreated similar conditions in laboratory experiments, providing strong evidence that this process is possible. Although no spacecraft has directly observed diamond rain yet, it remains one of the most exciting and scientifically supported hypotheses about the giant planets. If confirmed, these worlds would truly have the most dazzling weather anywhere in our solar system.